All right, we are recording. Hi, everyone. Welcome to the day 3 of the Forge Online Bootcamp. For those of you who maybe don't know me, my name is Peter Braz. I'm a Forge developer advocate, and I'll be your host for today's webinar. I'm saying some of you may not know me because this is the first time this week where we have a joint group. This webinar is basically language agnostic when it comes to the server side, because some of you may have joined me in the previous days for the Node.js tutorials, and some of you might have joined the .NET versions. But today we're basically going to be working strictly on the client side, so it doesn't really matter what language you used for the server side, and you'll be free to use actually any of the applications that we built in the previous days using Node.js or .NET. All of those will work. All right, and since again, there might be some of you who are joining us today for the first time, let me again quickly go through some introduction and information about the event, how it works, and the schedule. So the online bootcamp is an event that we've been running for a couple of years. It's an event where we try and help customers who prefer a more guided approach when getting started with Forge, when learning what Forge can do. So instead of just reading through some of our online resources, maybe some of you prefer to have a more guided approach where you want to see us live code through the tutorial and then follow our steps, and that's exactly how this event is structured. It's a 4-day event where every day we cover a different topic, a different tutorial, and except for today, except for Wednesday, all the other webinars are provided for both .NET and Node.js alternatives. So you can choose whichever of these programming languages is closer to your heart. And we also run the webinars for both the EMEA audience, that's the webinar we're doing right now, and later our colleagues will present the same content for the Americas audience as well. Now, every webinar is split into 4 sessions, roughly of 1 hour followed by a 30-minute break. And during every session, we basically live code. We go through a part of that specific tutorial for today, and you follow our steps. That's the idea. And then we take the 30-minute break where you can ask questions. If you got stuck on anything, we can help you out. You can go grab a snack, go for a quick walk, and then after those 30 minutes, we come back to the next session. And by the way, this is a question that many attendees ask. All these sessions are recorded, and we will share these recordings with you after the event. We're not sure if that's going to be links to Zoom or maybe YouTube videos, but either way, you will get links to all the recordings of these sessions. So don't worry if you missed any part, you'll be able to revisit these recordings later. All right, the schedule for the week. Today it's Wednesday, and today we're going to be looking at the dashboards tutorial. And this tutorial is one of the new tutorials that we've been working on, right? So we've basically taken the Learn Forge content that some of you may be familiar with. That's the learnforge.autodesk.io website. And we've tried to, modernize them and make them really remove all the unnecessary old dependencies, make them use some modern JavaScript constructs and modern features of both on the client side as well as on the server side. And the dashboard tutorial is one of those new tutorials that we're going to be covering today. So I'm really excited this is going to be the first time us running through this tutorial, and I really hope that you'll like it. All right then, so we're on day 3 dashboard tutorial. Now, let me open that link in my browser here. Oop. And let me also share that link with you in the chat so that you don't have to retype it by yourself. This is the dashboard tutorial. You should see the link in the chat. This is the topic of today's webinar. Now, compared to the previous days, this tutorial is a little bit different because it does not build something from scratch. It actually builds on one of the previous days, or one of the applications that were built in previous days. So that's actually something we're going to ask you to do today as part of this first session, is to prepare one of the existing apps. Maybe if you had already joined us for day 1 or 2, you're more than welcome to use the application that you built during those days. But if you're also joining us, if you're joining us for the first time today, that's also fine. We have a way for you to grab a complete implementation of one of the apps that we presented in days 1 and 2. Alrighty. Let's see. So this is the application we're going to be building today. It's basically, we're going to start leveraging the viewer APIs heavily to customize the viewing experience, right? We're going to add custom buttons into the toolbar. We're going to start using the viewer APIs to query all sorts of information from the model that's currently loaded into the viewer. And we're going to add custom panels, show some aggregated information, and make the custom UI also change the state of the viewer itself, right? As you can see here, we're going to add some grids, charts, and some summary panels. And we're also going to link those back to the model so that, for example, when you click on one of those chart elements, or when you select click on one of the lines, rows in the grid, you will actually change the state of the model in the viewer, right? So like isolating things, hiding, or moving camera, navigating camera to a specific element. All that, I think this is really the power of Forge, where it's great starting point to be able to preview more than 60 different file formats in the browser without any plugins. That by itself is pretty awesome, I think. But then when you can start using something like the viewer APIs to, again, querying information from your model, maybe linking in information from completely different data sources, like real-time data, or some ERP systems that you might have, or custom databases, and then you can if you realize that you can then take these external data sources and start bringing them into the viewer, right, and present that information in different ways in form of annotations or charts, or maybe color coding design elements, all that you can do with the viewer APIs. And that's where you can really add your value and start building these really cool custom user experiences for your customers. So this is what we're going to be building today. All right, and the agenda in this first session, again, this was a bit of an introduction for those of you who may be here with us for the first time this week. And we're also going to go over some of the requirements for the dev environment and for the programming languages, so that we're sure that we're all on the same page and that we're ready to start coding in session 2. And as part of this session, we're also going to cover the way for you to obtain an existing Forge application in case you don't have one available. Session 2 is we're going to start building our first viewer extensions. Extension is a concept in the viewer where you could just start sprinkling your client-side JavaScript logic all over the place. Any JavaScript logic using the viewer APIs, but then of course that is kind of hard to reuse later if you wanted to reuse that logic in other applications, or something like that. That's why the viewer has the concept of a viewer extension, which is typically a class that encapsulates some sort of custom viewer logic that you've implemented using the viewer APIs. And that extension is then nicely, again, encapsulated and can be easily shared with, across different projects that you might have, or maybe with other teams. So that's what we're going to be covering in session 2. Session 3, we're going to start diving deeper into the viewer APIs. We're going to be building something like a model summary panel, where we're going to add a custom panel. We're going to implement a custom panel in the viewer. And in that panel, we're going to start, showing different aggregated values, information from our currently loaded model. And finally, in session 4, we're going to see how we can bring third-party libraries like some, chart components or grid JavaScript libraries, third-party libraries, how we can bring them into the viewer as well and populate them with data, which is a pretty common use case in a dashboard type of application as well. All right. Transition 1, introduction. First of all, since we're going to be loading models from Forge, we want to make sure that you can actually talk to the Forge platform. And for that, you will need two things: a Forge account if you don't have one. And if you don't have one, don't worry. This is some you can get an account for free. You can get a trial subscription that's valid for 3 months. So if this is your first time working with Forge, simply head over to forge.autodesk.com and you should see a button saying sign up Forge for free or something like that. That will create an account, a Forge account for you. And then under that account, you can start creating your Forge applications. Or what these are for, basically, you can create a Forge application as a set of credentials that you will then use to communicate with the Autodesk Forge platform, right? So you can think of these as, I call them Forge app credentials, because really you're not creating an actual source code at that point. When you're creating a Forge application, you're just creating a record in Forge saying, okay, please get me some sort of username and password that my own code will later use to communicate with the Forge platform. We're going to take a quick look at that as well, just in case you don't have a Forge application created. It's going to be really important because, again, the two important values you'll get from that Forge app, the client ID and client secret, are the sort of username and password of your app that you need to set up for your app in order to be able to communicate with Forge, to upload files, translate them for viewing, and then load them into the viewer. Next part is the development environment. Now, again, it's, we now have both groups in this webinar, Node.js folks and .NET folks, and you both groups are free to use the same programming language, the same application that they built in previous days. So just quickly, if you prefer .NET, just make sure that you have Visual Studio 2022 installed. You can get the free community edition, and make sure that you have the ASP.NET and web development workload enabled. The .NET desktop development workload is also recommended. That's something that's going to be needed on day 4 tomorrow for the configurators tutorial. Now, if you prefer Node.js, we recommend that you grab one of the later versions of Node.js, at least the LTS, that's the long-term support, which currently that's the version 16. So if you don't have Node.js installed locally and you want to use it during today's webinar, simply head over to nodejs.org and you'll see a link to download LTS. Why does it keep opening in a separate browser? So you'll see a link for 16.15. LTS version, or newer if you want. And again, this is because the new tutorials that we've been working on, we're trying to use more cleaner and more modern features on both on the client side and the server side. So we want to make sure that you're not using some older version of Node.js that may lack some of the features that we're using. And okay, and the way to find out what version you're running, and this is also something I like to point out, is typically in Node.js, I think it's pretty common in the Node.js world, it's common to work with command line or some sort of a terminal, right? So if you're on a Unix-based environment like macOS or Linux, you should already have a terminal application with bash shell available. That's what I have here. And in this case, you can simply find out the version of Node if you have one installed by running node-v. So in my case, I have even a more recent version. I have version 17.5, so I should be good to go. Same for, I believe, .NET. If you prefer going .NET way, the new tutorials are using .NET 6. So if I try run, I believe this is .NET -- version command. Yeah, so I'm running .NET version 6.0. So I'm good to go on that side as well. Now, if you are on Windows and you're maybe not sure how to work with terminal or command prompt, I would recommend that you check out Git for Windows, because Git is something we're going to need as well, right? Git is the really popular source code management system. We're going to use it to actually, for those of you who don't have an application ready to use for today, we're going to use Git to clone a complete app implementation from one of our GitHub repos. And I'll show you how to do that later. But if you're on Windows, I would actually recommend that you check out this Git for Windows, which is an official part, layer on top of Git that provides some utilities for Windows users. So this package installs both Git as well as a Git GUI and what's really important, Git bash. So you'll basically get access to a bash terminal on a Windows machine, right? So that's really helpful because then we can keep things consistent. And if you'll see me working in a terminal here, you know that on a Windows system you can open the Git bash terminal and you'll be able to use the same commands, right? Same commands that I'm using here. So I would definitely recommend that if you are on Windows and you don't have this tool available installed, definitely give it a try. All right. That is for the Node.js runtime. And as far as a code editor, you are once again free to use whichever code editor you prefer. If you're on Windows, you may already be using Visual Studio, so it's fine to use that. If you maybe prefer WebStorm or some others, that's perfectly fine as well. Later on, we'll just need to run the server app some way, so, somehow, so that we can open it in browser and start playing with our client-side JavaScript, right? So as long as you know how to run your app with, let's say, some environment variables, which is how we typically pass configuration options to our apps, right? If you know how to do that, you're free to use Visual Studio, WebStorm, Notepad, whatever you want, or Vim. Here, in my case, I'm going to be using Visual Studio Code. And again, if you're sort of unsure which way to go, I definitely recommend that you check it out. Visual Studio Code is this, I call it like this smaller brother of Visual Studio. It's cross-platform. It itself is built using web technologies. It's really fast and really nice especially for web development. So let's see if I can follow the link. Now it finally opens in the right window. So just go ahead and download and install the stable build. I already have VS Code installed here, and that's what I'm going to be using in my case. All right, that is the dev environment. And now finally, the starting point, right? The source code that we're going to start working with in session 2. As I mentioned earlier, you're free to use any of the applications you may have already built during day 1 or 2 this week, or this online bootcamp event. Or if you don't have one, we actually have complete implementations of both of these apps that were covered on day 1 and 2 for both .NET and Node.js. So I would recommend to just grab the simple viewer. That's the application we built on day 1. And it is available for both .NET and Node.js on the following URLs. So let me just open these in the browser and share the links with you in the chats. This is the .NET version, and this is the Node.js version. And again, you're free to choose whichever one you prefer. I'm going to be using the Node.js version of the Simple Viewer application. Now, what you'll want to do is, let me show you right now. So again, we're going back to a terminal, right? So if you're on a Unix-based system, you should already have Git installed. And if you are on Windows, if you install that Git for Windows package, you will get a bash terminal with the Git command available in it as well. So what we're going to do is for those of you who don't have an application to start with, we're going to clone the application from a GitHub repo to our local file system. And the way to do that is I'm just going to copy the URL, the complete URL of, in my case, the Node.js GitHub repository, and I'm going to go to a folder where I want that code to be cloned. I'm going to say git clone. I'm going to paste the URL. And you'll basically just grab a complete copy of the Forge Simple Viewer Node.js repo in this case, and it'll make it available in a subfolder here with the same name. So I'm just going to switch into that folder, and we're good to go, right? So this is my source code clone from GitHub. But now, of course, if I just try and run this app right away, that won't work, because there are a couple of steps, a couple of things you need to set up or configure before you can run your app. And these are described in the README file of either of the GitHub repos that I shared with you in the chat. So let's check what's needed there. Again, as I mentioned earlier, we're going to need a Forge application, right? So we're going to need this set of credentials, the client ID and the client secret, that our app can then use to authenticate itself when it's communicating with the Forge platform, right? Because we can't just let any arbitrary machine make HTTP requests to our Forge servers. They need to authenticate so that we know who that person making that request to us really is. So we need to generate or have our Forge app credentials ready. If you don't have them, don't worry, it's easy to set up. I'm going to go to forge.autodesk.com. I already have my account created, and I'm logged in. And using my profile icon in the top right corner, I can head over to the My Apps section. This is where I keep track of all the different Forge app credentials. Now, in my case, I have many of them already. That's because I like to create separate apps for different projects or different customers, right? Because individual apps, Forge app credentials are sort of like these silos where, of course, if I maintain and manage some data in one application, this data will not be accessible from other applications. And while I'm working with a specific client, I typically like to create a separate app for them. All right, and in this case, let me just create a new app. Just those of you who are joining us for the first time know how to do that. You can use this Create App button in the top right corner, and then you'll be asked to enter some fields for your app. Most of them are required, even the description, but you can put whatever you like in it. So I'm just going to say Online Bootcamp Day 3. That's how I'm going to name my application. And again, I need to give it some description as well. So I'm going to just copy the title. Callback URL in this case doesn't really matter what you put there. This would be important if you were developing an application using a three-legged authentication system where your app would actually allow users to log in with their Autodesk credentials and access their own data from other Forge-based products such as BIM 360 Docs or Autodesk Construction Cloud Fusion Teams. Now, it doesn't matter. I'm just going to use one of these values that my browser remembers. This is typically the URL that we use in our tutorials for these three-legged workflows. And my website URL, I'm just gonna put localhost in there. Or actually, I should change this. 8080 is the port that we're using. All right, and what's that? Okay, in that case, it's foo.bar. Problem solved. Now, at the end of the app creation page, you can choose which APIs you want your application to have access to. Now, unless you have any very specific reasons for limiting your app's access to the different Forge services, I would just recommend that you keep everything enabled. You can always come back here and disable if you think that some APIs should be made unavailable. I cannot really think of good reason for that, but you have the option to disable access to some of the APIs, some of the Forge services. All right, with that, we can create our app. And if everything goes well, yes, our app is now ready. And we have the two crucial values, the client ID and client secret, generated for us. That's the username and password sort of credentials of our app that we need to use whenever we're communicating with the Forge platform. So I'm going to keep this page open because I'm going to need these values very soon. If I go back to my GitHub repo, to the README file, you can see that we're actually going to be asked to pass in the Forge client ID and client secret to our app as environment variables. So let's try that. Let me go back to the terminal. And now, well, first of all, since I'm using npm or Node.js, I need to run npm install to install all the different dependencies that this application requires, right? These are captured in the package.json file that every Node.js project has. In this case, we see that, okay, this particular project requires 3 dependencies: Express, Express Formidable, and Forge APIs. These are basically, this is the web application framework that our app is using. Express Formidable is an Express middleware for handling file upload requests, because our app actually will allow us to upload files as well. And finally, Forge APIs is the official SDK for the Forge platform for Node.js. Okay, so if I type npm install, all these dependencies will be downloaded and made available to this project in this folder. All right, now if I list the contents of my project folder, I now see a node modules subfolder. That's where all these dependencies and their nested dependencies were installed. All right, so now let's try something. If I try and run, well, let me take a look at the package.json file one more time. I have a script here, yeah, called start. So now theoretically, if I wanted to run the app, I could just say npm start. And that's like, you know, on the .NET side, if you ran .NET run, and that should start my server, but it won't work. And I'm sure many of you know why. If I just try and run the app, I'm going to get an error saying missing some of the environment variables. That is because this particular app requires these 2 environment variables to be set because without those, it cannot really do anything, right? So we can see that here, there's actually a 3rd environment variable, but that one is optional. That is, if you want to specify provide a specific name of a data management bucket that you want your application to use. A bucket is something that we covered on day 1. That's sort of like this concept in data management service, which is sort of like a folder where you can keep a flat list of files. That's where your application can manage data, can upload designs there, translate them and load them into the viewer, things like that. So in my case, I think I'm just gonna leave the Forge bucket undefined so that I'm gonna let the application itself create a bucket for me. All right, so what I'm gonna do is here, again, I'm working with, I'm on macOS system, I'm in a bash terminal. So in this case, if I wanted to define some environment variables, I would use export. Now I can be careful for something like command prompt. This is different. I think in Windows, command prompt is probably, I think it's set, right? So you need to type in set, name of a environment variable equals something. On Unix-based systems, you use the export keyword to define an environment variable. So here I could say export Forge client ID equals, and I'm going to pass in my Forge client ID. Right, and similarly, I can say Forge client secrets equals. You can simply double click the secret here, and it'll get copied into your clipboard. And I'm going to paste it here. Now, let me take a quick stop here. You should never expose and share your client secrets with anyone. I'm doing that here, obviously, because I need to show you how to configure the credentials, the environment variables for your application, right? But you don't want to ever share these with anyone. That's like sharing your password. What I'm going to do here is I'm going to define these 2 environment variables. So you see my Forge client secret, but at the end of this webinar, I'm just going to use the regenerate button that's available on the Forge portal to basically have Forge create a new password for this particular application. All right, so now I have my 2 environment variables defined. And now if I try and run the app again, now it's running. Now it's ready, listening on port 8080. So if I go to localhost, port 8080, I can see my simple viewer application. Now it's not doing really anything, right? Because it's a fresh new app that has just generated a fresh new bucket that does not have any data in it yet. So what I can do is I would, for the purposes of today's webinar, I'm just going to upload a Revit file so that we have one, or so that I have one Revit file to play with when we're using the viewer APIs and adding the charts and grids and things like that. Now, if you, I would probably recommend, I mean, you're free to use whichever designs you want to use. But again, if you're not sure, you can actually get official Revit sample files online. If you just Google, you can try Revit 22 sample files or sample projects. That will take you to a knowledge.autodesk.com page where you can grab some of these sample files. So what I'm going to do is I'm going to download one of these. Let's say, which one? Well, maybe just the RAC basic sample project. And you know what? Let me share that link with you in chat as well, just in case you want to follow my steps and grab one of these as well. So I'm going to download the RAC basic sample. Some downloads. Hopefully that won't take too long. It's already there. All right, now what I'm going to do is I'm going to test my app, make sure that it's running properly. So now if I hit the upload button, I should have a chance to choose a file. Now the file is being uploaded to our simple viewer application. And as soon as it's uploaded, we're going to initiate a translation of this file, which is something that's typically needed before it's a one-time operation that you need to do before you can load something in the viewer, right? Because there is this conversion process where one of the services in Forge will basically take your design and it'll start extracting all sorts of information from it. Things like thumbnails, 3D geometry, 2D drawings, metadata that we can then query. So that's a one-time operation. And after that, once the conversion is done, you can then load the model into the viewer as many times as you want. All right, and while we're waiting for the model to translate, I see we have a question in the chat. How can we set the client ID and secret on Windows Git Bash? I believe that if you're using that Git Bash, you should be able to use the export keyword as well. Or another option is, so let me keep this server running, but you can also pass environment variables to a command from the command line by putting the key equals value pairs in front of that command as well. So let's say if I wanted to run npm start again, or .NET run to run the application, I could actually do something like this. I could say Forge client ID equals blah, blah, blah. My Forge client ID, right? Forge client secret equals blah, blah, blah. And then I could do npm start or .NET run. And that way, these two environment variables will be passed to the Node.js or .NET process as well. I hope that answers your question. So please give it a try and let me know. I believe that should also work in the Git Bash. All right. So let's see, we're at 65%. So we're basically now repeatedly pulling this one of the Forge services, specifically the Forge model derivative service. We're basically bugging the service. We keep asking it, okay, is it ready yet? Is it ready yet? Is it ready yet? We're asking about, the service responds with a JSON that includes some information about the different outputs that were found in that, this case, Revit file, and how far the conversion has gone, the percentage of the progress. So that's the information we're showing here in the overlay. And as soon as it's ready, we're going to just load the application will just load the model, the default output from this Revit model into the viewer, right? So that's it. Here, you can see there's typically Forge finds multiple outputs for an input file. Like in this case, it found a single 3D view and a couple of sheets, right? And you can switch between those as well using this document browser component that we also, this is actually one example of a viewer extension that we explicitly enabled in this simple viewer application. So this is not something that's available by default, but there is a one line of code in the simple viewer application. We can actually try and find it here. It's under the www root viewer.js, I believe. Yes, here. So as we are initializing our viewer class, viewer component, we are passing in a config object with a list of extensions that we want to enable. This is actually something we're going to be modifying as we are adding our own viewer extensions in the course of this webinar today. All right, and I see a good comment in chat as well. Yes, if you happen to be using Visual Studio Code, let me maybe show you that approach as well. So what I'm going to do, I'm going to stop the app running in a terminal, and instead I'm going to open Visual Studio Code in this folder. All right, so in Visual Studio Code, I'm going to say open folder, and I'm going to navigate to TMP, Forge Online Bootcamp, day 3. Day 3, was it? Yes, and Forge Simple Viewer Node.js. Right, so now I'm in the same folder that I had open in terminal before. Now, if I'm using VS Code, there is an easier way to run the app and even to debug it, because that way you not only just run the app, but you can also attach a debugger to it. So you can put breakpoints in the server-side code and step through the code, watch the state of local variables and things like that, which is pretty neat as well. And if you clone the GitHub repo, as I did, you'll see that there is a .vs code folder with a launch JSON file in it. This is a file that defines something called launch configuration. So in VS Code, you can have one or more launch configurations, which are basically just a couple of setups that tell VS Code how to run your application. So in this case, we have a single launch configuration, which basically says, okay, I want to start a Node app. I want to start it by running npm start command, which is, if you remember, the same thing I ran from the command line. And the cool part here is we can also specify this property called env file and give it a path to some sort of a file where that VS Code can read different key values from and set them as environment variables for this process that we're running and debugging here. Right. So in this case, and by the way, again, you get a nice IntelliSense when working with the VS Code files here. So if I were to add double quotes, you'll see that I actually get a list of all the different properties that the launch configuration accepts. Right. So here, in this case, we're basically just telling VS Code, hey, when I want to run and debug this application, look for a .env file in the workspace folder. That's the folder where we're working. So let's create one. And we're asking VS Code to read any key equals value line from here and parse it as an environment variable and pass those environment variables to the debug process. So we can actually just, instead of setting environment variables in bash or in command prompt, we can just define them here. So let me copy these values one more time. All right. Forge client secrets equals secret phrase. That's it. All right. And now with our launch configuration defined here, we gave it a name, launch server. We can head over to this run and debug sidebar in VS Code, and you'll see that there is a launch server configuration available. And if we run the app, this is actually the same thing as if we ran npm start from the command line. And on top of that, VS Code also sets the environment variables for us. And on top of that also, VS Code actually attaches a debugger to the running Node.js process. So what I can do then is, let's say, put a breakpoint somewhere in my routers, right? Maybe here where I'm getting a list of this /API/models endpoint that my client side is JavaScript is using to populate the dropdown. Let's put a breakpoint here and see what happens. I'm going to go back to our app. I'm going to reload it. And I can see, okay, now our JavaScript code in the client in the browser has made a request to /API/models to get a list of models, right? And since we are attached to that running Node.js process with the debugger, we can actually stop the execution here. We can jump over this line and see what's returned from this list object method. We can see that there is a single object returned in the list, and it has some bucket key, location, object ID, object key, and size, and things like that. And what we do is we just take this array and we call map. So we generate a new array where every item of the original array is mapped into a new object with just two properties, name and URN. URN, for those of you who don't know, is the base 64 encoded version of object ID, right? Object ID is what we're going to be using in different places to load files into the viewer. But object ID, like in this case, let me check. If I look at the only item in the list, object ID looks like this, right? It contains colons, slashes, and it may contain other characters as well. So this string is considered unsafe for URLs, right? Because if you take this string and you put it in a URL somewhere, it may mess up the meaning of the entire URL, right? Because it also contains these characters like colons or slashes. That's why, to keep the IDs safe for URLs, we base 64 encode them. So that's why we have this helper function called earnify, which will take the original object ID and it will base 64 encode it. Base 64 is like basically taking any input buffer of bytes and turning it into lowercase letters, uppercase letters, and numbers, I believe. So that output string might be a little bit longer, but it's safe to be used in a URL because it's just letters and numbers. So that's what we're going to do, right? We're going to return a list of JSON with a list of objects, in this case, just one, that'll have a name property and a URN property. And the URN is basically what the viewer will be using to load the design in our web application. And that's what happened here. All right, so our app is running. Now it's running from VS Code, so we can even debug the service side if we want to. And I saw another good comment in the chat. Yes, if you do go this way and you add a .env file, right? Again, this will contain information that you don't want to share publicly, right? So you can see here in VS Code, it's already grayed out. And that is because in my git ignore file, I added the .env file. So basically this way I'm telling Git, hey, whenever I want to take my code and send it to GitHub, for example, ignore this file, right? So we don't want to share this file on GitHub. That's of course not really desirable at all. So if you're adding .env file in your own project, always remember to add the .env file to git ignore file to make sure that your credentials are not sent to GitHub at some point. All right, so our app is running, and I believe that is it for the session one. So we have a little bit of time left in case there are any questions. So let's see. If you have any question or also a comment or feedback on the tutorials or the event itself, the presentation and content and the form of presenting the content, please let us know. We definitely want to improve this event for you to make it work for you as much as possible. So let's see, no questions. All right, in that case, I can give you back a little bit of time. So we will meet back here at 9:30 GMT or UTC time, which should be roughly 45 minutes from now. So in the meantime, please make sure that you have a Forge account and Forge application ready. That means client ID and client secret, that you have dev environment set up on your machine, and that you have one of the applications ready to run, right? So again, if you were with us, if you joined us day 1 or 2, you can reuse one of these applications. If you're joining us for the first time today, just clone one of the simple viewer source codes from GitHub, either for .NET or Node.js, and follow the README file to make sure that you can, run the app successfully. And maybe if you have a completely new app, also go and grab one of the Revit files from the knowledge.autodesk.com website that I also linked in the chat, just to make sure that you have some model to work with as we start working with the viewer APIs and as we start querying the model so that we can display some data in the charts or grids. All right, I see there's a Q&A. All right, I got this error, cannot find module express. All right, thank you. So this is also something to be careful about, and it's something that's explained in the README file. Let's see. I go back to the Node.js version of our project, you will notice the second step of setup and run is install dependencies. If you see a message saying cannot find module express, that's because you probably haven't run the npm install. So you're trying to run the application that expects some dependencies such as express to be available, and it's not. So that's one typical issue, one thing that can happen, right? And the same thing applies for .NET. In .NET, there might be some dependencies like Forge SDKs that are required. Oh, it looks like I actually don't show it here. Oops, okay, I didn't realize that the README steps were not included here. So if you're using .NET version, you basically want to clone the app, use .NET restore, I believe is the command, right? That's the one that installs all the dependencies that are defined in a CS proj file. And then you can just type .NET run after setting the environment variables. Those steps are the same. And the other issue potentially that, the other potential problem that could be causing this is that you ran the npm install, or maybe that you're working in a different folder, right? So here you should be really in the folder where the package.json file is located. This is where you should type npm install to install the dependencies, and this is where you should run npm start to run the app, right? If you maybe accidentally are in the folder above or some other folder, of course this will not work. All right, and there's one more comment or question in the Q&A. I've cloned the .NET project. I've added client ID, client secret, and when uploading Revit file, it's giving me this. Could not upload model. Could not upload model basic sample project RVT. See the console for more details. So in that case, if you get this error, please try and okay, is my app still running? Yes, it is. If you get that error in the browser, please try and open the console. If you're using Chrome, that's done through these three dots. You can go to more tools and developer tools. This is what we're going to be using a lot in the upcoming sessions to debug the client-side JavaScript code that we're going to be building. Now, in the console here, you should see some error, some more details on what's going on there. So if you cannot upload file to your Forge application, please check what you see in the console and let me know. Okay, so with that, let me pause the recording, pause the sharing. I'll still be here to answer questions. I'm just going to go grab a cup of coffee, and I'll see you all back here in roughly 40 minutes so that we can move on to session 2. All right, talk to you later. Okay, we're recording. Hi, everyone. Welcome back to session number 2, where we're going to start implementing our first viewer extension. So hopefully everybody is all set, up and running, and we can move on to building our client-side viewer enhancements. In this session, we're going to be working basically with this step, the basic extension step of the dashboard tutorial on the tutorial website. We're going to start by implementing our very first viewer extension just to understand how that scaffolding typically looks like. As I mentioned earlier, this is typically a class that you then have to somehow register so that the viewer is aware of it, and then you want to load the extension into the viewer. So we're going to see how that is done, because that's the same process that's going to be reused then when we build additional extensions that will add the custom UI and charts and grids. And then we're also start exploring some of the first viewer APIs for doing things like handling different types of events coming from the viewer, or querying the metadata, the information about our model that's currently loaded in the viewer. And then in the end of this session, we're going to implement another basic extension. This one is going to be simply logging information to the browser console. That's going to be the starting point, right? So we want to familiarize ourselves with how the extensions are implemented and set up, and then we want to learn some basic viewer APIs. And then in the next session, we're going to start actually creating some custom UI and adding more capabilities to our extensions. All right, with that, demo time, let me move on to the basic extension. All right, so here, the green tip is actually what I was suggesting earlier. If you don't have an application to work with, this is how you can get the Node.js or .NET version of the Simple Viewer app that's covered by the Simple Viewer tutorial, how you can get it running on your machine. All right, and also, by the way, all the code that we're going to be adding now, all of it will go into the www root folder. So basically, no matter whether you were following, whether you're using the day 1 or day 2 application, on whether you're using .NET or Node.js, in all cases, it's always going to be the www root folder that contains all the client-side assets. That means all the files that the browser will need, things like HTML, CSS, JavaScript, static images, and things like that. So we will be adding our extension code, all of it, into the www root folder, into a subfolder called extensions. So let's start by implementing our very first extension. We're going to call it base extension. And this is basically the scaffolding. That's the same process that will be repeated for every extension that you develop. It's just a class that extends autodesk.viewing.extension, right? That's going to be our extension object. And in there, the extension base class contains some methods that you can override to control or to react to different lifecycle points of our extensions. For example, typically the methods that are overloaded are methods called load and unload. These will be called by the viewer whenever it loads or unloads our extension. So we can use it to do things like set up new event handlers or create new UI elements, or release those resources when the extension is unloaded. So what I'm going to do is let me copy this code and head over to Visual Studio Code. As we mentioned, we're going to be working in the www root folder. We're going to create a subfolder called extensions. This is where we're going to define all our extension code. All right, and I'm going to create a new file called baseextension.js with uppercase B and uppercase E. No, yes, no. I'm going to paste the code from the tutorial website. So basically now what we're doing is, this is a super simple extension. It's not doing anything really. It just overrides the load and unload methods, and it returns true from these calls, indicating that the loading and or unloading was successful, right? In some cases, maybe there could be some problem, in which case we would return false instead. And also you can see the constructor always accepts 2 parameters, viewer and options. Viewer is going to be the instance of the actual Forge viewer object that is loading the extension. right? So we can use this to, again, attach maybe event listeners to the corresponding instance of the viewer. In case we had multiple viewers on the same page, this will help us differentiate which of the viewers our extension actually belongs to. All right. Now, first thing is event handling. What we're going to do is we are going to add a couple of event listeners. So here we're already using first method of the viewer APIs. So also, here's what I'm going to do. I'm going to go back to forge.autodesk.com. I'm going to go to the documentation section, because all these methods that we're going to be using are available in the viewer reference. Typically, why am I not seeing anything? There we go. So I'm going to head over to viewer documentation. And under the API reference, I'm going to go to viewing, that's the namespace, and to viewer 3D. So this is basically the basic viewer object and really the entry point for most of the viewer operations, right? This is where we're going to find all the different methods to load models, to load extensions, to change the state, to change selection, read the current selection state, isolate objects and everything. That's really the entry point for most of the viewer operations. And here we can, let me go back to our code, or actually go to our tutorial website. So you can see that here we're already using something called add event listener and remove event listener. These are methods available on the viewer object that allow us to set up listeners for specific event types, right? These event types are the first parameters to these methods. So in this case, for example, we're setting up a new listener for the event called object tree created event. This event will be called anytime when a model is loaded and when the viewer finishes loading its metadata that contains the logical hierarchy, right? So logical hierarchy is what you see in the model browser in the viewer. That's the things like, in case of Revit, the categories, families, and family types and instances. So once that data is loaded and parsed by the viewer will emit this type of event, and we can react to it. So here we're basically setting up some sort of an event. So we're providing a method that should be called when this event is triggered. And the same thing we repeat for other types of events. So selection changed event will be triggered by the viewer whenever the user changes the selection of something in your design. And isolate event will be called whenever somebody will either manually or programmatically change the isolation state in the viewer. So isolation means when you isolate some parts of your design, these parts will remain visible and everything else will be completely hidden or made semi-transparent, just to make the isolated elements pop up, sort of. So we create these 3 event listeners in our load method, and we remove these listeners in our unload method. And then we also provide the empty function, the empty methods that will be called on the individual events. And there is one tricky thing that has to do with how JavaScript works. If we simply added this dot on model loaded method pass as a parameter to the add event listener or remove event listener, the meaning of the this keyword used inside these methods would be something else than we would expect, right? Because if we simply wanted to call, let's say, on object tree created, and see, I'm noticing I don't have that here. It's actually a typo. I need to fix that. So if we were simply to call on model loaded and pass that method as a parameter to the add event listener, the code running inside this function, this keyword would have a different meaning. That would actually be the viewer, and not this keyword would not be referencing the instance of our extension as we would expect. That's why we do this trick where in the constructor, we create 3 these like helper properties, basically, where each property will be just a simple fat arrow function calling our actual class method with this dot. So that means that whenever one of these events is triggered, this is simply to make sure that this keyword inside these functions or methods will be the reference that we expect, meaning that this keyword will actually be a reference to the extension object itself. So it's a little bit of a mouthful. You can find more on this online about how this meaning, the keyword changes meaning depending on the context in which it's used. All right, so let me grab this code and update our base extension. All right, so we are adding our 3 event listeners and removing them on the unload lifecycle event. And we have these 3 methods prepared that will be called whenever the corresponding event is triggered. For now, these are empty. That's fine. This is our base extension. And then in other extensions, we can override these methods to add some logic that will be executed when these events happen. All right. Now, querying metadata. So as I mentioned earlier, when you upload your file to your designs to Forge and you run the conversion job on them using the Forge model derivative service, that job will extract all sorts of information from your designs, all the 3D geometries, 2D drawings, thumbnails, the logical hierarchy as you see here. For example, for Revit files, that's the categories, families, family types, instances, and also the metadata. So every design element can have its own metadata attached to it. That's the metadata you typically see when you open the properties dialog in the viewer. And the same data you can actually query programmatically using the viewer APIs. And we're going to add a couple of helper methods into our base class that will help with that as well. So you can see here, again, modifying our base extension.js file, we are going to add 2 methods. Let me grab them now, copy them in VS Code, and explain what they're doing. I'm going to add these methods at the end of our base extension class. So we have a method here called find leaf nodes. This is something that will be helpful later because oftentimes when querying different metadata, oftentimes you'll want to collect this metadata only from the objects that are the leaves in the logical hierarchy, meaning that that's only the objects that don't have any more children, right? So because those objects are typically the ones that contain most of the metadata information on them. Okay, and we can maybe run the app real quick so that I can explain what that means. Let's go to localhost 8080. It's the basic, that's our Revit model. All right, so this is one of the, this is the official Revit sample file I uploaded earlier. And here, if I open the model browser, I'll see the logical hierarchy, the data that Forge was able to extract from my design, right? So I can use the logical hierarchy to then navigate, like filter. This is the isolation actually taking place. I can look at different types of walls, move the camera to them, or just highlight them or isolate them. And then using the properties dialog, I can also check the different metadata that Forge was able to extract for individual elements. So if I select this wall, I see some metadata on it. And again, most of the metadata typically is available on the leaves in the tree here. So meaning objects that don't have any more children, right? If I were to look at the basic wall, right, I only get a name, right? Or maybe here, I may get more information if I select, let's say, this SIP 202mm wall, but then I get most information when I select, when I go to the individual leaf nodes. That's why it's important and helpful to be able to find the IDs of all the leaf nodes in our model. And here's how we do that. In our method, we return a promise, so this method will be asynchronous. And we call model.getObjectTree. Now, model is going to be an instance of a class called model that represents the actual design loaded into the viewer. If I go back to the reference, you will notice that in the viewing namespace, there is a class called model. And it's basically going to be the one that we're using here. So you can see it has methods like get instance tree, or I don't know, is leaflet, get root. It's got, it's got a couple of different helper methods that you can use to query the information about that specific model. And get instance tree is something we're going to be using in our code actually, or get instance or get object tree. That's the same thing. It's an asynchronous operation, right? So we're going to ask our model to give us an object tree or instance tree. So a structure, data structure that represents the logical hierarchy that we saw. And in a callback, when that tree is retrieved, what we're going to do is we're going to call a method on that tree object called enumNodeChildren, which basically means give us all the children of a specific object ID. And we find that object ID by calling get root ID. So that basically means we take the very root node of the logical hierarchy, and we use this enumNodeChildren method to retrieve all its children. And by passing in this true parameter, we're basically asking for a recursive enumeration. So this code, whatever we pass in the callback, will be executed for the root node and all its children and their children and their children recursively until the very bottom of the tree. And what we do inside this callback function, we're basically asking the tree object if this current node with this specific DB ID, if it has 0 children. And if that's the case, we push that ID into a list. And finally, we return the list. So this is all we're doing, right? So this helper function, again, it retrieves this logical hierarchy data structure in memory from the currently loaded model. And it goes through all the nodes in that tree, and it keeps asking if those nodes have any children. And if they don't, this code collects the IDs of these nodes, these leaf nodes as we call them, and it returns them, right? So this information will later be used. So for example, when we want to retrieve information from different types of metadata, we will often only want to look for this metadata in the leaf nodes. So this method will be helpful for that. And you can see we are already using this logic in the other method here called find property names. This is something that might come handy in later as well. This is a helper method that will, first of all, you can see already here, it will retrieve all the IDs of the leaf nodes. That's the helper method we just discussed. And with this list of DB IDs, and by the way, these stand for database IDs. And with this list of DB IDs, we call another method on the model object called getBulkProperties. What we can do is we can go back to the documentation of our model class and search for getBulkProperties. There it is, right? So you can see this method accepts a list of DB IDs or object IDs that we want to retrieve the properties for. And it also, you can pass in some additional options, like maybe filters to only retrieve specific type of properties. And then it expects a success callback function and an error callback function. These are the functions that should be called if the properties are retrieved successfully or if the data retrieval fails. And that's what we do here. We're basically saying for this input list of object IDs, give us all properties. And in the success callback, we go through the results and we only collect the names of the different properties, right? So basically what our helper function here is doing is it'll go through all the leaf nodes in our logical hierarchy of the currently loaded model, and it will collect all the different property names that appear across those design elements, right? So it's not collecting values, it's just collecting the names. And this is something that might be helpful in the future as well. For example, if we want to have a dropdown where the user will be able to select some specific type of property that is available in the design elements, like a material or area or volume, right? This helper method will find all the property names for us. And that is it for our base extension, I believe. Yep, that's it. So now what we're going to do, because that extension, base extension, is really just a base class, right? We're only going to use it as a base class for other extensions that we will be implementing today, so that in those other extensions, we don't have to worry about re-implementing event listeners and some of the common, again, like finding leaf nodes, right? All that functionality is going to be available in the base class that we're going to derive from. Right, so now we're going to create another class, another JavaScript file under the www.root/extension folder. We're going to call it logger extension.js, and that's going to be the extension that actually does something. And in this case, this extension will log all the different events and information about our model into the browser console. So let me copy the code again, bring it into VS Code, and explain it in more detail. I'm going to create a new file under the extensions folder, call it logger extension.js with uppercase L, uppercase E, and paste the code. Now, one important thing to notice, you may have noticed earlier that the base class actually uses this export keyword, and now that the logger extension is using this import syntax. This is because we're now using a more modern approach on the JavaScript side, where we're using something called ES6 or ECMAScript 6 modules. That's where JavaScript files can import each other and export different symbols using this import-export syntax, right? So instead of us having to bring all the individual JavaScript files in the HTML page manually, we can just have a JavaScript file import classes or functions or variables from another JavaScript or ES6 module using the import syntax. So that's what we do here. So we're basically only bringing in the base extension class from the other file, and we're extending it with this new class called logger extension, right? And we overload, or we override the load and unload methods just by calling, super.load and super.unload basically means executing the code from the parent class that we derived from. And console.log, we just output some information into the console when the extension is loaded or unloaded. Now we also override the three methods that the empty methods that we created earlier, right? That will be called whenever an event of certain type is triggered. So the onModelLoaded method will be called whenever a new model is loaded. Selection changed, same thing. Isolation changed, same thing. So again, what we do is we call the super, basically we call the original implementation of the parent method. And in this case, when the model is loaded, what we're going to do is we're going to use the helper method called find property names to retrieve all the names of properties across the leaf nodes, and we will output it to the console. That's really it, right? That's all it's doing. And similarly for the selection change, whenever the selection changes, we just output the list of selected object IDs into the console. And then when the isolation state of the viewer changes, we output the new isolated IDs into the console as well. That's all for our logger extension, really. Now, the important piece is here is, as I mentioned earlier, also, there are a couple more steps that need to be done in order for this extension to be loaded by the viewer. First of all, we need to register it. Register the extension under some unique name, and so that the viewer can later load the extension under that name. That's done through this one-liner, this Autodesk Viewing the Extension Manager. That's basically a singleton object in the Autodesk Viewing namespace that represents a global extension manager, a manager for viewer extensions. So we call a method called register extension, which accepts two parameters, a string and the actual class that we want to register under that unique ID. So here we're basically taking our logger extension class and registering it under the name logger extension. You can name it whatever you want, but then you want to use the same unique ID in the viewer code. That's it for the logger extension class itself. Now, the next part we want to do is, of course, we want to bring this logger extension code into our application now. And since we're using ES6 modules, we don't have to include this a new script tag in the HTML. All we need to do is just go to our main.js file, which is already an ECMAScript ES6 module, and we're just going to add this import statement. So go to main.js, or maybe just a viewer. Well, both would work, but okay, let's go to viewer.js. This is also an ECMAScript module. And at the top, we're going to say import extensions logger extension, right? So this is, again, the ECMAScript 6 syntax for importing the entire file. We're not saying import something from, we can just say import the file. So we are making sure that the additional file, JavaScript file, is loaded and parsed by the browser, but we don't necessarily need to cherry pick any special symbols out of that module. Because we don't need to do that, because the logger extension itself will already register the class with the viewer extension manager under a specific ID. And then what the last thing we need to do is update our list of extensions that we're loading into the viewer when it's during the initialization with the ID of our new extension, right? So we named it logger extension, so I'm going to use the same name, and I'm going to add logger extension string at the end of this extensions list, right? So this basically means, okay, so now we are successfully bringing the logger extension code to our application, and we are also configuring the viewer to load our logger extension as it initializes itself. All right, so let's restart the app and give it a try. See if that works. I'm going to open the console, and you can do it through the three dots, more tools. No, that's here. More tools, developer tools, or in case of macOS, that would be Option Command I. Let me reload our application. All right, so you can see this is the logger extension loaded console log that we already have in our extension. And here, this is the code from our logger extension, where as soon as the model is loaded, we basically collected all the IDs of the leaf nodes in our logical hierarchy, and we collected all the property names from these objects, right? So we see that across all the leaf nodes in this particular Revit design, there are a total of 474 different property names. Names like type comments, URL, frame material, there's really a lot. Type name, type image, default thickness. Of course, this will differ for different designs that you upload to a Forge application. This is specifically for the Revit design that I used here. All right, so this works. And now if I try and maybe clear the console, if I try and select anything, maybe the roof and the wall with holding the Shift key, you can see that now we're also getting another console log from our logger extension, reporting that currently there are 3 objects selected, and they have the IDs 2213, 2590, and 4045. And if I try to maybe open the model browser and, I don't know, let's see, click on all the windows, you'll see that now the isolation actually reports that there is a single isolated node. That's the Windows group here. So this actually is not giving you the isolated individual leaf nodes. This is telling us that there is a group in the logical hierarchy, in this case Windows, that is now isolated. If I were to only select maybe one window, it will get isolated as well, and the isolation will be reported in the console, as you would expect. And that is it for our code in session 2, I believe. Let me check if I have missed anything. Nope, that is it. Now let me check if there are any questions or comments. There's some Q&A. All right, what is the difference? Okay, good question. What is the difference between get bot properties and get bot properties 2? Right, let me go back to the documentation. Yes, so there are two flavors, get bought properties and get bought properties too. Sometimes this can happen where we need to change the APIs, but we don't want to break backwards compatibility. In certain cases, for example, I believe with get bought properties, you will get external ID field as well. So external ID is another concept in the viewer where each element in your design will have its own DB ID. That's like the internal IDing scheme used by the Forge viewer file format. It's just integer numbers, as you saw, when we were getting the list of selected objects, or selecting or getting the list of isolated objects. Whenever you're using the viewer API to get information about what's selected, for example, or when you're using the API to select or isolate or hide something, you will always be using DB IDs. These are just numbers, integers, sequential integers. But oftentimes, you may want to get a more persistent ID of a specific element. Imagine that maybe you want to select a wall in your Revit model, and you want to maybe store this ID of that window somewhere in your database with some additional information, so that maybe later on when somebody opens the same model, you may want to query your database for the same data for the same window. But the numerical ID may not be the same if you retranslate the Revit file, or maybe if you create a new version of the Revit file, the ID of that window, numerical ID, may not be the same. That's why we also provide this concept of external IDs. These can be like string values that are persistent, meaning that if you have a Revit model with a window, that will have some external ID. In case of Revit, that will be a Revit GUID. But then if you modify that Revit model and you translate it with Forge again, the window will have the same external ID, right? So that's a persistent type of ID that you can use, let's say, in your databases where you want to store some additional data for the design elements. Unfortunately, retrieving the external IDs is a costly operation. And that's why we provide, I believe in get bought properties, the external IDs are always provided. And that's what makes this operation a bit more expensive. And that's why we added get bought properties too, where the external IDs are actually excluded by default. And as you can see here, the external IDs will only be requested if you explicitly specify so. Right, and of course, we could not just change the get bought properties method here, because that would be breaking backwards compatibility, because other applications, our customers may already be using this method, expecting that it always returns external IDs, right? That's why sometimes we have to work around that by adding an alternative method like this to avoid breaking backwards compatibility and still allowing users to use a more efficient way of retrieving properties for multiple objects at the same time. So I hope that answers the question. And there's one more, why we're loading and unloading extensions every time. Well, that's because oftentimes the extensions may need to react to a specific, may only work with maybe a 3D model, right? Or may only work with a 2D drawing, or maybe they always need to refresh their state when the viewer changes from one model to the other. So that's why this is typically done where when you're changing models within the single instance of the viewer, the extensions are unloaded and then loaded again. Okay. All right. And with that, how are we doing time? Okay, this is pretty good. So next step would be session 3 would start at 11 a.m. UTC or GMT time. That should be roughly what, an hour from now. Yes. please make sure that you have your base extension implemented and your logger extension derived from it and load it into the viewer. If you ran into any problems, drop me a note. And again, I'm going to pause the recording, pause the screen sharing, and I'll be monitoring the chat and Q&A to make sure that everybody is up to speed and we can meet for at 11 a.m. to move on to the next type of extension where we're basically leveling up, and that next extension is going to start adding custom UI to the viewer. All right, so I'll see you in about an hour. Wonderful. All right, we're back for session 3. Thank you for sticking with me. In this session, we are going to, like I said, level up our viewer extension writing skills. Now we're going to create another extension where we're going to start adding custom UI to the viewer. So that's another thing, that's another aspect in which you can customize the viewing user experience using the APIs. You can add custom buttons to the toolbar. You can change the toolbar itself. You can create custom UI panels that have the same styling as the panels used by the built-in panels, like the model browser, properties panel, and all the others. That's what we're going to do in this session. This session is going to be a little bit shorter. We're just going to build a single extension. This one, we call it summary extension. So just to showcase what kind of functionality you can add, where this extension is going to collect some aggregated information from the selected design elements, such as, so for example, if we're working with Revit files and maybe the different Revit design elements contain properties such as volume, area, or mass, the summary panel will basically try and, for example, add together all the volume of all the selected components, which might be a small but useful feature, right? Where if you select a couple of, I don't know, walls in your Revit model or a couple of elements in your Fusion or Inventor assembly, you may get the total mass information for the selected elements. All right, that's what we're going to do now. So it's demo time. It's my turn to code, and hopefully you'll be able to follow along. Let me go back to our Forge tutorials website and let's switch to the model summary part. That's what we're going to be focusing on in this session. All right, so we're building a new extension, again, under the www.root/extensions subfolder. This time we're going to call it summary extension. So let's start with that. And again, for now, we're just overriding some of the methods of the base extension class, right? So load and unload, we just override these methods to just output something to the console, just reporting, hey, this extension is being loaded or unloaded. And we also override the on model loaded, on selection changed, on isolation changed methods, so that we can then introduce some custom code when any of these changes happen. And as you can see here, we actually have centralized all the logic that should be called whenever any of these events happens. Whenever any of these events happens, is we're just going to call this asynchronous update method that we're going to modify later. So let's just start with the scaffolding. I'm just going to copy the code of the extension and bring it into Visual Studio Code. So again, under the extension subfolder, I'm going to create a new file called summary extension and paste the code there. So again, what we're doing is just making sure that when any of the 3 events happens, that's the model loaded or selection changes or isolation changes, we're just going to call our update method, which is for now empty. That's fine. And we again must not forget to register our summary extension with the viewer extension manager, just like we did with the logger extension. All right, and we also need to, again, bring this new extension into our application, right? Into our JavaScript main.js file, or viewer.js file, sorry. So I'm going to open the viewer.js file, That's under the www root folder. And I'm going to add another import statement to make sure that when the browser loads this viewer.js file or ECMAScript 6 module, that the browser will also make sure to download and execute and evaluate these other JavaScript files, also ES6 modules. All right. And we want to make sure that this extension will also get loaded with that specific viewer instance that we are creating in the initViewer method, right? So let me just, again, add another extension ID, and we call this one summary extension. All right, so now when our viewer is initialized, it will, apart from all the standard default extensions, it will load the document browser, logger extension, and summary extension as well. Now the next part is we can start modifying our, let's actually go back to the base extension, right? That's the one that all our extensions will be derived from. And let's add a new helper for UI. Right, so we're going to find the base extension that we implemented previously. We're going to add another helper piece here. We're going to add two new methods called create toolbar button and remove toolbar button. So let me grab these and bring them into the base extension class. And again, let's quickly take a look at what these are doing. So again, we are using this.viewer to access the viewer, the reference of the viewer that owns this current extension, right? And the viewer, among other many different methods, properties, also has a property called toolbar. This is a property that contains the reference to the actual viewer UI toolbar that we can use to get information about what buttons are there already, what controls. We can add new controls, right? So what we do here is we first call get control method on the toolbar object to find out if there is already some sort of control with this specific ID. Okay, this is something we came up with for this particular demo. So we're trying to see if there's maybe a toolbar control called dashboard toolbar group. And if there isn't one, we create a new Autodesk viewing.ui control group. So all the different UI components are typically available in the Autodesk.viewing.ui namespace. And again, you can find the documentation for these on the developer portal. So we're going to create a new control group, which basically means just a group of one or more buttons or drop downs, for example. And we add it to the toolbar. All right. And then we create a new toolbar button with some specific ID that's going to be an argument to our helper function. And we set some information for it. We set some tooltip, again, coming in as an argument to our create toolbar button method. And we add the button to our new toolbar group. This is typically done so that, if you have multiple buttons that you're maybe adding to the toolbar, that you group them separately from the default buttons, from the default toolbar options. And we also define an icon. So the way we do it here through CSS, a little bit of DOM API and CSS. So we basically find an element inside the button container, right? So button is our instance of Autodesk Viewing UI button, and the container property is really just a reference to the underlying HTML element. So on that element, we call the standard query selector, which will basically return the first HTML element that matches certain query, right? In this case, we're looking for any nested HTML element that has the class ADSK button icon. And when it's found, if it's found, we set its CSS styling, basically. We set some background image, the URL of which is also passed in as a parameter to an argument to our method. And we set some standard, like we make the icon size 24 pixels, make it centered, not repeated. So that's how we create our toolbar button, right? So again, we're putting this helper method in our base extension class because other extensions may need to use this type of logic later as well. And similarly, to remove a button from the toolbar, we simply use the toolbar.getControl method one more time to get the group, our specific group with our special extension buttons, and we remove the button object from it. That's it. All right. Now we can go back to our summary extension. That's the new one that's the new extension that we're building in this session. That's going to display that custom panel with aggregated information. And let's extend it so that we keep a reference to that button that we create whenever, as soon as it's needed, and we remove it during the extension unload. Now you may have noticed here that we're not creating the button in the load method. We actually are using another special lifecycle event or method of the Autodesk.viewing.extension class called onToolbarCreated. This method will always be called when the viewer finishes initializing the toolbar, and it's a good practice to initialize our UI at this point for one important reason. It is possible to initialize the viewer to be headless, meaning that we just want to see the canvas with a 2D drawing or with a 3D model, but we don't want to see any of the UI, any of the toolbar or view cube or anything else, or any of the Chrome really. It's just a headless, that's what we call a headless viewer. And in those cases, of course, the toolbar will never be available, right? So it's a good idea to put any UI toolbar initialization into this onToolbarCreated method, because if somebody wants to use our extension, maybe the extension doesn't need to use the toolbar, right? But if they, just in case, if we implement our extension this way and somebody tries to use our extension in a headless viewer, the stuff won't break because this method will never be called. And as you can see here, also in the unloading, we check if the button is initialized at all. And only if it is, we try and remove it from the toolbar. All right, so let me grab this. Instead of copy pasting these highlighted added lines, let me just copy the content and bring it back to the summary extension file. All right, so that's it. So in our constructor, this is not strictly needed, this line of code. This is just to, inform whoever's reading this code at the very beginning that, hey, there's going to be a property in this class called _button. To be aware that this is an actual property of this class object instance. All right, so when the toolbar is created, we call our helper function, a helper method. We create a button with the ID summary button. We point it to some kind of an icon URL. You can use whatever images you want. Here I'm just using some icons from the icons8.com website, and a tooltip, whatever should appear when you hover that button in the toolbar. And the toolbar, the toolbar button object also has a property called onClick, which you can set to any sort of function that should be executed when the button is clicked. For now, this is empty and doing anything. And then when the extension is unloaded, we check if that button is in fact initialized. And if it is, we remove it from the toolbar and we basically just null the _button property to make sure that this object is garbage collected. Now we're moving to the next piece. So when this button is clicked, in our first toolbar button, we want to make sure that we bring up a custom panel that will show some of that summary, that aggregated information. So we're going to create another, we're going to put this code into a separate JavaScript file just to keep things neatly organized. So we're going to create a new file under the www.root extensions subfolder called summary panel this time. And here's what it's going to look like. In this case, we're not creating another extension, right? We're grabbing one of the classes in the Autodesk Viewing UI namespace, and we are subclassing, in this case, property panel. So property panel is a standard UI class in the viewer that is used for any type of panel that contains key value key value pairs displayed, right? Just like the standard properties that you see when you select, when you click the properties button in a viewer. So you can see there's key value pairs, and they're also grouped in categories that you can collapse and expand. And the same functionality we basically get from this Autodesk Viewing UI property panel class. So we call our class summary panel. And here, let me copy the code again into VS Code and go over more detail there. So in the extension subfolder, we create a new file called summary panel. All right. And here's we're implementing two methods on this summary panel class. One called, let's start with the bottom one, aggregate property values, right? Because this is basically the piece of code that we're going to run to aggregate the information across multiple object IDs, right? Here, that's going to be basically the second argument to our method. First is the model that we want to grab the information from, and DB-IDs is the list of IDs of the objects, of the actual elements in the model that we want to grab the information from. Then the third parameter is going to be the specific type of property that we want to collect the data for. And this little trick here is, the fourth parameter is going to be some kind of function that will be executed for the values, for the specific values of this property across the selected objects, right? So this can be, this aggregate function might be a function to sum the values, or to compute an average, or to find a minimum and maximum, like the typical aggregation type of computations. And initial value for that aggregated value, that aggregated function. And what happens inside, we call model.getBulk properties. You are already familiar with this one. This is what we used for the base extension. So this method on the model object will basically allow us to retrieve all or just filtered specific properties from selected object IDs. In this case, we're basically only asking for the values of just the single property that we're computing the aggregate for, right? And when the data is retrieved successfully, we go over all the results, right? And we basically keep calling the aggregated function, whether it's summing or finding minimum, finding maximum, or computing average, right? We're computing this value, we're calling this aggregated function repeatedly on every value of every found of this property across the selected object IDs, right? And once we go through all the values of this property for all these object IDs, we return the aggregated result, whatever was the final result of calling the aggregate function. And here is where we're using our helper function. That's in the update method. So this is the actual method that we will call whenever something in the viewer changes, when we want to update the content of our summary panel, right? So whenever, for example, the user changes the selection, or whenever the model changes, or whenever the isolation changes. So what we do there is we call a method that is available on the property panel class called remove all properties. That does the exact thing that exactly what it says. So it'll remove all the properties from the panel. And then what we do is we go through a specific list of properties that are, again, passed in as an argument. And for each one of these, we call our helper function, this aggregate property values, and we pass in our custom aggregate function. And what we do here, this is the function that's basically going to be called for every value of that specific property across all objects, all the object IDs. We basically, our function will compute the total count and the sum of all the values and the minimum of all the values and the maximum of all the values. And it'll return them as an object with these 4 properties. That's basic. So basically, we have a single aggregate function that computes all these four aspects: the count, the sum, the minimum, and the maximum. Right? We call our helper method to compute this data across all the DB IDs for that specific property. And if the number of results found for this specific property, we call this add property method on the property panel to basically to add these computed results back into this empty property panel. And the syntax and the parameters for the add property method is, first of all, is the key, then the value, and the third argument is the category, in case you maybe wanted to have multiple categories to collapse or expand, right? So here, what we're saying is basically our property panel will have key values that will be count and some number, sum and some number, average and some number, minimum followed by some value, and maximum followed by some value. And all these five values will always be grouped into a category that will be the name of the property, right? So let's say our update method can be called for two different properties, for let's say volume and mass, right? So in that case, our property panel will end up with two categories: volume with count, sum, average, minimum, maximum, and mass category with count, sum, average, minimum, maximum. So that's basically what we're doing here. All right, now how do we bring this summary panel into our extension? We can again use the ECMAScript 6 syntax, right? We're going to import summary panel into our summary extension. Let's go back to our summary extension and import the summary panel from the same folder, so we can use this / syntax, right? Because summary panel is available in the same folder. And we're going to prepare a member variable for the panel as well. We're just going to call it _panel. And in the unload method that we are overriding, right, if panel is defined, we're going to hide it by calling the setVisible method on the property panel object with false, and we're going to uninitialize it, basically release all the resources that it uses, and set the actual member variable to null. We can also add, and we will initialize the panel just like the toolbar button when the toolbar is created. Let me actually copy the entire content of the onToolbarCreated method. All right. So what we do here is we create a new panel instance and a new toolbar button. And then when the toolbar button is clicked, we toggle the visibility of the panel, right? So we basically use this panel.isVisible method that will return true or false depending on whether the panel is visible at this point. And we negate that Boolean value and set it back to as an argument to this setVisible method. This is a way to toggle visibility of the panel, nothing else. And then we also update the state of the button, the toolbar button, to indicate that we can actually tell the button to appear as active or pressed, right? So that will be a visual cue to the user that this button has been clicked, that it's enabled, and that's why we're seeing the summary panel. Okay, that's it. And finally, if the panel is currently visible, we call this update, right? That's the method on our summary extension class that will be called whenever something changes, whenever we need to update the actual data in the UI panel. And that's something we'll add here in the update method of our extension. I can do that here. Now this is where we actually control what design elements we compute the data for, right? So we basically say, okay, if the panel actually exists, right? Because again, we may be running in a headless mode where the viewer does not have any UI components. But so only if the panel is enabled, we use these two new methods of our viewer object, get selection and get isolated nodes. These return list of IDs, right? List of IDs that are of objects that are either selected or the list of IDs of objects that are currently isolated. And we say, okay, if there is at least one object selected, these that we consider these in this case highest priority. So if the user selected at least one object, we will update our summary panel based on the selected objects. Or if nothing is selected, we check if at least some elements of our design are isolated, meaning that if the array has at least one item, and if that's the case, we update our summary panel with the aggregated data for whatever is isolated. Otherwise, and if there's nothing selected and nothing isolated, our fallback is basically we call our helper function one more time, find leaf nodes, to find the IDs of all the objects that don't have any more children, right? All the leaf nodes in our logical hierarchy, and we update our summary panel with aggregated data for all these leaf nodes. And the final piece, if you remember, our summary panel update method expects 3 parameters. And the third one is the list of properties for which we want to compute these aggregated values. And this is something that will now, you can tweak according to your needs, because if you're working with Revit models, you will most likely want to compute the aggregates for some typical properties that appear in Revit, right? So again, volume, level, maybe, or maybe it doesn't make sense to compute some for levels, but volume, mass, area, stuff like that. But if you're maybe working with other types of designs, maybe Fusion or Inventor, there might be different property names that you would like to compute the aggregates for. All right, so in my case, I'm just going to grab this constant that I have defined at the top of the summary extension JavaScript file. Maybe I'll modify it. So in this case, maybe in my summary panel, I only want to show the aggregated values for maybe area, or maybe just volume, mass, and price, right? So with this, our extension, our summary panel should show the count of sum, average, minimum, and maximum for these 3 properties, or, well, to be precise, for the values found under these 3 property names in all the objects, in all the design elements that I either selected or isolated. Okay, so now let's double check in our viewer. Yes, we are bringing the summary extension in, and we are including the extension ID when initializing our viewer class. We are bringing in summary panel and initializing it when the toolbar is created. That is looking good. And we are updating the panel whenever something in the scene is selected or isolated, or even if none of that is the case, we update the aggregates in the panel based on all the leaf nodes in the design. All right, let's give it a try. Let me just reload my app just in case. Let's go to localhost 80. Let me open the DevTools just in case there's any error, so we can see it right away. Let's switch to the Revit project. All right, this is looking good. So now you can see we already have a new group in the toolbar with a new button, right? That's the summary. That's the button we added with the summary extension. And now if we click that button, that should bring up the summary panel, right? The summary panel is already instantiated, but it's not visible yet. Click that. All right, and we have our model summary, right? So you see, okay, so now I only see volume, and that's because it's possible that of all the leaf nodes currently that you can see, there's 89 of them. only these 89 objects only have the volume property on it, right? So none of the objects have mass or price. So we can maybe check, let me try and select the roof. And now what will happen is, since I'm going to change the state of the viewer, right, I'm going to change the selection state, the model summary will be updated just based on the selected object. So if I click on the roof, you can see that now, or maybe the wall here, you can see that, now the summary extension just says there's just one item, and the sum, average, minimum, maximum is the same, obviously, for the volume property, because we only have single object selected. Now, if I try and hold Shift and select another wall, you see that now we have actually two elements, and the sum, average, minimum, maximum is now different, right? So the smaller of the walls has the volume of 8.15, maximum is 9.06, and the average and the sum corresponds to these values. I can take it further. I can try and Shift select, Shift select. Pressing caps lock. That's why. I Shift select additional walls. You can see that now I get even more information. Now, maybe I want to see other properties as well. So let me just try and select one of the walls, bring up the properties, and see what other types of properties I have here that maybe I want to show in my summary. So I have the volume, and there's a length and area. Oh, here it's called cost. So maybe we could try cost instead of price. Let me go back to my list of summary properties, and instead of price, look for cost. All right. There we go. Okay, so there we found 433 objects with cost property available on them, but unfortunately, it looks like this value is set to 0 in all these 433 cases. So not very helpful. So let's see, maybe there's another type of property we can try. Maybe this absorptance. Let's see if this one provides some more interesting values. Reload the page one more time. Okay, well, nothing special, but okay, so you can see that of all the objects, the leaf nodes in this design, 61 of them have this absorptance value defined on them, but you can see that all of them are basically set to 0.1. So the average is obviously 0.1, and the sum corresponds to the sum of these values, 61 times this value as well. So nothing exciting. And again, when you get to this point and you want to start exploring the summary information, again, make sure that in your code that you are actually computing the aggregated values for some kind of properties that are available in your specific design file. So if you're working with SolidWorks or Bentley DGN files, the properties there might have different names, right? So adjust these based on the designs that you're working with. All right, and that is it for session 3. So again, time for any questions, or if you ran into any issues, you can ask now. Again, I'll go grab something quick to eat, and I'll be monitoring the chat and Q&A. If you don't have any questions, I'll see you back here at 12:30 p.m. It should be roughly an hour from now. Yes. All right. So thank you, and I'll see you later. Okay, hi everyone, welcome back for the final session, session 4 of our webinar today. This is where we're going to add 2 more pieces of functionality to our viewer, 2 more customizations. It's going to be this custom UI panel with a chart and a custom UI panel with a data grid. We're going to try and reuse some of the logic from the earlier sessions to populate the data in the charts as well as in the grids. For the charting, what we're going to do is we're going to select a specific property name, let's say material or volume or price or cost. And we're going to collect all the different values that appear for this property across all the elements in our design that's currently loaded in the viewer. And we're going to display the number of occurrences of the different values in either in form of a bar chart or in form of a pie chart. And similarly for the data grid, we're going to show a selected subset of properties and their values in a standard table-like interface. And we'll make these new UI components interactive so that, for example, when you click on one of the bars in the bar chart representing a specific value of the property, we're going to isolate or highlight all the objects in the scene that have this property set to this particular value. And you'll see exactly what I mean when we get to the live demo at the end of this session. Alrighty. So we're moving to session 4, and now we're looking at the histogram charts section of the dashboard tutorial. So what we're going to do is we're going to add another extension. We're going to call it Histogram Extension. Add in the same way as previously, we're going to add a button to the toolbar that's going to be used to show up either a bar chart or a pie chart. We're also learn this other aspect of viewer development, and that is a recommended way of loading dependencies into the viewer, because now if we want to start showing charts, we will most likely need some third-party JavaScript library. In this case, we're going to be using charts.js, open source library. So we need to bring the dependencies of that JavaScript library into our application as well before we can start creating charts. And the same goes for the data grid. And we'll also add a new type of panel, UI panel, just like we added a summary panel earlier. Now we're going to create a panel that we can then populate with the actual graphics of the chart output of the charts.js library. And after that, we will immediately jump to the other piece where we're going to add a data grid extension that will be using a third-party JavaScript library as well. This time it's one called a tabulator, and we're going to bring the dependencies for tabulator into our application as well through the viewer extension. And we're going to add another UI panel to actually host the grid visualization. All right, so with that, let's go back to our Forge tutorials website and let's move to the histogram charts section. As we mentioned, again, we are working in the www.root/extension subfolder. And let me just copy the initial content of the histogram extension into VS Code, and let's go over it in more detail. So this is called Histogram Extension. All right, and what we do here, again, this is a new extension derived from the base extension that we implemented in the first session. Excuse me. And we are once again overloading the load and overriding the load and unload methods to just inform in the console that our extension is loaded or unloaded. And now this is going to be the important piece where this piece of JavaScript will basically make sure that for a given model loaded into the viewer and for a given property name, we go through all the leaf nodes. Once again, we're using this helper method from the base class, find leaf nodes, where we find all the IDs of all the objects that don't have any more children, that are the leaf nodes in the logical hierarchy. And we collect just just the one property that we're looking for from all these objects, right? And then when we're going to use this to build a sort of a histogram, or in other words, we're going to use it to build a data structure in memory that will keep track of which are the different values that appear for this property and how frequently they appear, or which objects they appear for, right? So for example, if you imagine that we will pass in the material as the property name input to this function, right? So we will be looking for all the different values that appear for the material property. So there might be values like wood, steel, glass, and things like that. Again, if we're working with a BIM model. And this histogram map object will basically keep track of all these different values like steel, wood, glass, as the keys of the map. And then the value of each key will be a list of IDs of objects that have this material property set to either glass or steel or wood or whatever, or concrete. And we return this map once it's computed, right? So this method is going to return, again, a map, sort of a dictionary where the keys in this dictionary will be the different values of the given property. So again, the key could be wood, or another key could be concrete or steel. And then the values of each key will be a list of numbers. And that's the IDs of objects that have that corresponding value available on them for this property, for the material property, let's say. All right. And again, we are registering our extension under some specific name, in this case, Histogram Extension. And if you remember, the next thing we need to do is, again, make sure that this extension is, the code of this extension is loaded into our application. So we will do that by going to the viewer.js file and adding the import statement for the histogram extension. Again, making sure that the class is actually brought into the browser and parsed and evaluated. And we also want to make sure that the histogram extension is loaded when we instantiate our viewer. So let me just break this to multiple lines. We're already loading quite a few extensions. So to make this easier to read. All right, so we've got a couple of extensions from earlier, and now histogram extension will also be initialized and loaded when we create a new instance of our viewer object. All right, and again, going back to creating some basic UI in the toolbar. This time we're going to be adding two buttons, one for showing or hiding a panel with a bar chart, and one for showing or hiding a panel with a pie chart. So let me grab these two fields that we set in the constructor of our histogram extension. And again, this is just to let whoever is reading our code know that this class actually contains two more member variables, bar chart button and pie chart button. And during the unload phase, we check if the buttons are defined. Actually, we should actually do that here. Should say if button, then remove toolbar button, right? So here we once again are reusing the remove toolbar button method from the base extension class that will simply remove this object from the viewer toolbar. And then we set the references to null. And similarly, when the toolbar is created, that's again the lifecycle event method that will be called by the viewer when and if the toolbar is actually initialized to the viewer. And we're going to use that to populate, to create the two buttons. And again, we give them some IDs. I'm once again reusing some icons from the icons8.com website and some title, right? And whatever will happen after clicking on the button, that's still to be defined for both of these. All right, that's for our UI. Now we're getting to the dependency loading, right? Now, so again, typically when you are trying to reuse some sort of a dependency, some third-party JavaScript library in your web application, like a chart library or data grid library or whatever other library, even viewer itself, right? You need to bring some dependencies into the web application. You need to bring in some JavaScript, some CSS files, and potentially other assets as well. You could either, just hard code these dependencies into the HTML itself, but that is not really flexible, right? Because then your extension will depend on something that has to be manually added to the HTML. So then if you wanted to take your, let's say, histogram extension or charting or data grid extension, if you wanted to share it with somebody else, that extension would not work for them automatically unless they manually added the same charts.js or tabulator or whatever other third-party libraries into the HTML. So instead, what we're going to do is we're going to go back to our base extension class, and we're going to add a few more methods that the rest of the extensions can use to load and insert third-party dependencies into the web application. So you can see at the bottom of the base extension class, it's getting a little bit long. At the end of the base extension class, we are adding two more methods, load script and load style sheet. Let me copy those into the base extension class. So find the base extension JavaScript file, and at the end of the class, add two more methods. So load script and load style sheet. These methods do exactly what based on how they're named. Load script will basically expect a sort of a URL with some third-party JavaScript, and it will create a new script HTML element and insert it into the head of our document, right? And through that, the browser will make sure to download and evaluate the JavaScript file. Here, to make sure that we're not unnecessarily loading the same thing twice, we're also expecting a second parameter, a namespace, some kind of a name that we will try and look for in the window, in the global scope. So that, for example, if we're looking for a global scope, a class called chart, we can add this, we can put the chart name as the second parameter to our load script function. And we first check if there is maybe already a chart symbol or class or whatever in the global scope. And if there is, we automatically return. And if there's not, it's only then that we initiate the process of inserting a new script HTML element to our head tag, right? Causing the browser to fetch the JavaScript dependency and evaluate it. And for style sheets, there's this would be a little bit more tricky to have some logic to try and find out if a specific CSS file has already been loaded or not. So here we just accept a URL for the style sheet, and we once again insert it into our app by creating a new link tag in the HTML and inserting it into the document head as well. Right, so these helpers we can then use in other extensions, just simply passing in a URL to either a JavaScript file or a CSS file, and these will make sure that our extension can actually bring in third-party dependencies, which then has the benefit of the extension being really encapsulated and reusable, so that anybody else can then take this extension, drop it in their own Forge Viewer application, and the extension will make sure to bring the dependencies that it needs. All right, that is for the base extension. Now, let's create a UI panel for our charts. We're going to create a new file, histogram panel.js this time. We're going to define a new class called histogram panel. Now, if you remember earlier, when we were building the summary panel, that one was derived from a class called property panel, right? It was autodesk.viewing.ui, the property panel. In this case, we need a little bit more generic type of panel, right? Because this time we won't be inserting key value pairs grouped into categories. And this time we want to build a panel that's just a blank div container that we can then put our charts into. So that's why we're using a more general version of the panel class called dogging panel, right? So that's basically a superclass of property panel. It does not have any, methods like add property or remove all properties. It just has a basic container HTML markup. And so this is what we're going to do here. Let me copy the code and explain it in VS Code. So this is going to be a histogram panel.js file under the extensions folder. Histogram. Histogram panel.js. All right, so let's take a look at it. So again, it's derived from Autodesk View UI docking panel. And what we do is in the constructor, we just prepare the styling for our panel, right? So container is really the container defining the entire panel UI in the viewer. So we just set the some dimensions and position for this panel element, and we also take in we expect a chart type option that can be passed to our constructor, telling us which type of chart we actually want to show in this panel. By default, we use bar, and for the other types, you can check out the documentation for the chart.js library. And then we actually create the chart. Now let's see what this method is doing. We're simply calling new chart. So see, this is a class that will be available in the global scope after we bring in the chart.js dependencies, the JavaScript file and the CSS, right? The chart itself, the library needs a 2D canvas context to render the charts into. So that's why we actually create a new canvas element inside our panel, right? That's what happens in the initialize method that we override. So initialize is a method of the docking panel. We override it here, and we do that so that we can, apart from creating a standard title, the title, the header, grab that the header piece that you can grab with your mouse cursor and move around. And apart from the standard stuff like adding move handlers so that you can actually grab the header panel and move it around, we create new content for this panel. And the inside of that div container, we just include a select element for some sort of a drop down and a canvas HTML element. This is where the chart will be rendered. And then we simply store the reference to the drop down element and the reference to the canvas element by using the standard DOM API as a query selector, right? So we're basically looking for a select element with a class called props. And we're looking for a canvas element with a class called chart. That's this one. And then we insert our custom div container, our div element, into the panel itself. All right. And finally, we have two more methods. One called set model. This one's going to be used whenever, let's say, a model changes, right? So in our viewer, we can as soon as we change the dropdown, we switch to another model, we will need to update the information in the charts, right? So what will happen here is, as soon as the model changes, or somebody tells us that there is a new model that we should be displaying the charts for, right? We just use the find property names, which is once again, the helper function from the base class, right? That finds all the different names of properties appearing across the different objects, right? So this again, we could either hard code some small set of property names that we want to let our users choose from, or we can just use the viewer APIs to get the list of all the different property names that appear in the design and show those in the dropdown instead. All right, and then what we do is we take this select objects, that's our HTML dropdown element, right? And we populate it with option tags representing the individual choices, right? The individual property names. And then we say, okay, whenever the selection of this dropdown changes, we want to update our chart. And then we also immediately update the chart based on whatever is selected in the dropdown. And finally, update chart is the method that will actually recompute the values to display in that chart. Right, so this will be called whenever we want to update the chart for a specific property name. So what we do is we call our helper function that we discussed earlier that will return a dictionary of all the different values that appear for this property and how frequently or what objects this value is appears on. All right, and then we basically just manipulate and modify the chart object right? We changed the labels based on the new values that were found for this new property. And we change the data set. That's really the data that appears in the bar chart or in the pie chart. We change the label based on the new property name that we found the occurrences for. And we change the data to actually represent the numbers, right? So how many times the wood value appears on a material property, how many times the concrete value appears on the property. And here we compute we try and define some sort of a color for every one of the values found for this property. And then since we have modified the data of the chart in memory, we need to call chart.update to actually have the chart.js library refresh the rendering of that chart. And we also configure an on-click event handler so that when we click on one of the bars or on one of the pie segments of the pie chart, we want to do something, right? And in this case, what we do is we try and retrieve the list of IDs that correspond to that one, pie segment. So let's say if we click on a pie segment corresponding to the concrete value, right? In the result, in the histogram that we receive from our helper function, we can actually find for concrete, we can find a list of objects or a list of IDs of objects that have the material property set to concrete. What we're going to do here is we're going to isolate them by using the viewer APIs. And we're going to make sure that we're going to use another handy method of the viewer object called fit to view. That'll make sure that the camera automatically moves and zooms in so that it is only looking at the provided object IDs. All right, that's our histogram panel. Now we just need to tie it up to our histogram extension. So what we want to do is bring the histogram panel, import it into our histogram extension. Define two more member variables on our histogram extension class. Load the dependencies when the extension is loaded. Right, so in this case, when the histogram extension is loaded, we call the helper load script method from the base class, base extension, right? To make sure that we load some specific JavaScript dependency for the chart.js open source library. And in this case, we're also passing in the chart name so that before trying to load this dependency, the code will first try and see if there is a chart object in the global scope. And only if this global object is not available, only in that case will the load script method load the actual dependency. And here we just disable legend for the chart. So it's not that the legend is not going to show up. All right, now for unload, we're going to make sure that panel, that the bar chart panel and pie chart panel is uninitialized. So we need to hide them first and then uninitialize them to release all the resources that they might be using. All right. And then let me just grab the entire onToolbar created method, bring it in. When the toolbar is created, again, we create a pie chart, a bar chart button, and we also create new instances of the histogram panel, right? So we give them some IDs, some titles, some default options, and you can see here, this is where we're defining the chart type, right? So this is how we can just instantiate the same class, but just by setting this one different type of option, change the type of chart that the data will be visualized in. Right, so we created two chart panels and we created two buttons that toggle the visibility of these panels, right? So we create a bar chart button, and when it's clicked, we toggle the visibility of the panel, and we also change the state of the button. And similarly for the pie chart button, when it's clicked, we toggle the visibility of the pie chart panel, and we toggle the state of the button. And finally, we want to make sure that the charts are updated when we maybe switch to another model, right? So that's why we are once again overriding this on model loaded method here. And if you remember, this is the method that the base class will call every time the viewer triggers the event, that the new model has been loaded. So that's what we do here. We call any logic in the parent class for this method, and then we say, okay, if bar chart exists and it's visible, we call the set model on it to update the rendering with the new data. And the same for pie chart. If it exists and if it's visible, we call set model to basically update the contents of the pie chart based on the new model that we have just loaded. And that's it. So now let's give it a try. I'm going to run the app and go to localhost 8080. Open the DevTools one more time, just in case something pops up. So we have our Fusion Wally. Let's try the Revit model instead. All right. So now if I use this bar chart button, there we go. There's our bar chart. Now this isn't very helpful because we chose currently to find the occurrences of different values for the element ID property. So that's not ideal because it's very likely that element ID is going to have different values for every single element. So let's try something else. Let's try something like material or something like that. Let's see, material. Oh, all right, there we go. See, so it looks like for the material property, our extension found 5 different values that appear on these objects, on the design elements for this property. It found 44 objects that have this property set to glass, 144 objects that have this property set to metal, paint, finish, dark gray, matte, 3 objects with material set to brass, 10 with material set to iron, and 2 objects with SH aluminum and anodized black, anodized black. Right, so that works, right? That's pretty cool in its own, right? So we now have this quick way of get a visual overview of the number of occurrences of different property values. But the nice part is that, if you remember, we configured the on-click method for the bar chart elements or pie chart elements. So what we can do is when we click on this glass bar, we actually isolate everything that's made of glass and we hide everything else, right? Then you can see our logger extension is still aware of that. And now that we set isolate to only so isolate everything made of glass, we get the IDs of all these objects thanks to our logger extension as well. Or maybe we want to show everything that's made of iron. We can even try other types of materials. Types of properties. I'm not sure what would be a good example for Revit type of designs. Maybe, is there anything for lighting? No, not a lot there. Maybe level. All right, there we go. So we found, again, like 200 objects with level set to 2, a couple of them with level set to 7, 5, 3, 6, right? And again, by clicking any of these bars, we will filter everything. We will filter or isolate all the objects with the level set to that specific value. In this case, with level set to 6 or level set to 7. I'm not sure why this has level set to 7, but that's what's in the data. All right, and then we can try the pie chart as well. That works in the exact same way, right? So we can, again, choose mark, I don't know. Let's try something else. Thickness, maybe. Right, so we can, here we found the different values that appear for the thickness, right? So 46 objects have the thickness set to 25.4, and we can click on the pie segment to have these objects highlighted. So this is, looks like this is a thickness for all the windows. There is a 144 objects with thickness set to 100. And that seems to be maybe the frames of the windows. Right, so this is a nice way to quickly, investigate the type of data that you have in your design, whether it's Revit design or Fusion, Inventor, SolidWorks design, and to sort of filter through the data based on different metrics, right, different properties. So now let's try something. If I switch over to another model, let's say to the Wally model I have here, I'll have different properties, right? Because Fusion models provide different types of properties. But I can still use these, right? I can still try the, let's say, the material or the, I don't know, appearance. It looks like appearance has a couple of options, right? So some of the objects have appearance set to paint, metallic, or plastic, glossy, and I don't know, glossy, or steel, glass, right? So I can still quickly navigate and sort of like, slice through the 3D design based on the properties and their values. So that's our histogram extension. Okay. And the other one was the data grid extension. And for this one, once again, we will create a new extension file. This time we're going to call it data grid extension with uppercase D, uppercase G, and uppercase E. We'll bring in the initial code. Data grid extension. Data grid extension.js. All right, and again, what we're doing here is we're deriving from base extension, and we're using these helper methods from the base extension to load dependencies for our grid component. In this case, we're using a third-party component called tabulator. So we're bringing in the JavaScript file as well as the CSS that the tabulator component requires. And then we just, again, report to the console that our extension is loaded or unloaded. That's the basic for our data grid extension. And then again, as usual, we want to make sure to bring the code into our app by using the import statement in the viewer.js file. And we also want to make sure to add the data grid extension to the list of extensions we want to include when initializing our viewer. All right. And again, let me just grab the whole piece here. We're adding a toolbar button. Replace the entire content of the data grid extension here. So we're adding a toolbar button and initializing it when the toolbar is created, and removing the button when the extension is unloaded. All right. Now we're going to create one more panel class. Again, deriving from Autodesk Viewer and UI docking panel, right? That's the same class we used earlier for the charts. That is just vanilla HTML content. And we're gonna make sure that we actually populate it with the grid from the tabulator component. Right, so let me grab this code. And this will be in a file called data grid panel in the www.root/extensions subfolder. So I'm going to create a new file here called data grid panel. Let me hide the config for now. Let's take a look at what we're doing with the class itself. So as before, we set some initial styling for the HTML container that defines the panel itself, right? Some dimensions and position. And then we, again, override the initialize method of the docking panel class so that we still create a title and make it draggable as usual. But then again, we create a customized content for our table, right? So in this case, we create a div container where the tabulator grid will live. And here we immediately initialize the tabulator and make it basically sit inside this div element here, because the tabulator expects a selector string as the first parameter. So by using this dot notation, we're basically saying find the HTML element that contains this data grid container class. And that's this div that we inserted into the custom panel. And some basic configuration here. You can specify, layout, how many columns there should be in the grid, and what exactly they should be showing, grouping or reactions to row clicks or anything. So this is all captured in this data grid config object that we're at the top of the file that we're going to review in a second. And again, we expose an update method that we will be able to call on this panel whenever we want to update what the table is listing in the panel, right? And what we do, again, we accept specific model and the list of IDs of objects in this model, and we collect specific types of properties for these IDs using the standard get.properties method, right? And then we simply use this table.replace data to clear whatever rows were in the table until now and populate the grid with new rows based on the new results we received from the get.properties method. And again, how exactly we take the results from the viewer and turn them into data grid rows, this is also captured in this data grid config object at the top. So let's see what this is doing. Right, so here, this is basically where we put all the information about what columns the grid should have and how these should be defined. So what we say is, all right, so we want to include 4 different columns in our grid. We will call them ID, name, volume, and level. And again, you can tweak these to whatever, whichever way you want. And with the field property, you're basically telling the tabulator grid the name of the property of the JavaScript object where you should pick the value from for this particular column, right? So there's going to be some sort of object represented by every row in the grid, and the ID column will always pick the DBID property from that object to show in the ID column, and the volume column will always pick the volume property of that object, the value of the volume property to show in that column, right? And you can customize even some additional, like the width of the column, alignment, or maybe even custom visualization, how the cells in this column should be displayed. Progress basically means that we're going to take the value, numerical value picked from this particular property of our objects, and we're going to turn it into a progress bar going from the smallest value to largest value, so like indicating sort of like a progress. All right, then we also configure that we want all our rows in the grid to be grouped by some kind of property. In this case, we're going to say level. Again, this is all very AEC specific, right? So if you're working with different types of designs, take a look at the different properties that your design elements contain, and try and tweak this config to show different type of information. So maybe not volume and level or constraints, because this is very Revit specific, right? But maybe show other type of material or cost or price, whatever property names you find in your design. All right, and the create row is the helper function that is basically called when we receive all the properties from the Forge viewer model, right? And we want to turn them into objects that can be then consumed by the grid, right? And that's what we do here. So for every result, we pick the volume and level from the properties, and we return a new object, which is actually then used by the grid. So we need to be careful about naming the properties here, right? So we create an object that has 4 properties, one called DBID, one called name, volume, and level. And these are the properties that the column definitions are then looking for. All right, and finally, when somebody clicks on a row, we here decide to just grab, the object ID that's represented by that specific grid row, and we call isolate or fit to view, and fit to view to highlight that object and move the camera to it, right? So similarly to how clicking on a bar chart or pie chart would highlight the objects that have that corresponding property value and zooming the camera on them, similarly clicking on a row in the grid will move the camera onto that specific object that's represented by the row in the grid. All right. And then again, what we need to do is bring the panel to our data grid extension so that we can actually initialize it and toggle its visibility. Create a new class member in the constructor, right? Underscore panel. This is where we're going to keep a reference to the data grid panel. In the unload method, we want to make sure that the panel is unloaded and destructed, and that it releases any resources that it may be using. And let me just grab again the whole on toolbar created method. So apart from just a button, we're defining the panel, and the button then simply toggles the visibility of that panel and toggles its state as well to appear as active or inactive. And if the panel is visible, we call update method to actually update the contents of the grid. That will be covered by the last two methods here, on model loaded and update. So again, here overriding the on model loaded method basically means, okay, whenever the viewer triggers a new event indicating that the model has changed or has been loaded successfully, the base class will call this method and we override it. And in reaction to this event, we will basically call this update method, which will then in turn grab all the leaf nodes of the model, all the IDs of all the leaf nodes, right? And it will update our panel, the grid, based on these IDs. So again, we're reusing the same logic from the base class, finding the IDs of all the objects in the logical hierarchy that are the leaves that have no more children, right? Because these typically contain, most of the metadata that we're looking for. And we call the panel update method, which simply retrieves the required hard-coded properties, in this case, name, volume, and level, from our model for these object IDs, and it'll replace the data in the grid with these new values. All right, so let's see. Let's go back to our application and reload it. You can see now our data grid extension has been loaded as well. And we now see the fourth icon in the toolbar in this control group called saying show data grid. So let me go back to the Revit model one more time. And let's try this. And there we go. So this is our data grid, right? So now it basically, the extension took all the objects or the leaf nodes from the logical hierarchy and it tried and picked the name, volume, and level properties for all of these, right? And it created this data grid experience from these. They're grouped by level. If you remember, we specified that we want to group all the rows in the grid by the level property. So there are 76 items that have the level property set to level 1. And then there are, let's say, 34 items, 34 objects that have the level property set to level 2. And one of them has the level set to ceiling. And again, by clicking on the individual rows, right, we just call isolate and a viewer.fit to view to make sure that the camera moves the focus on that corresponding element. There we go. That's our data grid extension. Let me close this one. Right, so this is how you can start building your own dashboards, bringing custom information, combining it with the information extracted from your model using the viewer APIs, like the level or I don't know. Or costs. So I hope this is clear how this has been done. I hope that this gives you some ideas on where you could take this. next, and how you could start really implementing, adding your custom value to your Forge applications. And I believe that's it for session 4. So now I'm going to stay around for 30 more minutes to answer your questions or to discuss, whatever you want to discuss. And if you want to, again, still follow along, is implementing the last 2 pieces of the tutorial, the charts and the grids, as I just did. You can follow along the tutorial on the website if you haven't been able to basically code along with me. But again, you can still proceed, go through to the tutorial, or if you got blocked on anything, let me know now and I'll try and unblock you. Otherwise, we can call it a day today. There's one more day of the event, one more topic to cover. That's going to be the configurator tutorial. That's going to be covered tomorrow, again, individually for Node.js and .NET. Those webinars will be presented by my colleagues. And again, if you need more help, if you want to continue with your learning of Forge, and you are wondering where to get some more help, do know that we have different channels of providing help to our customers. First of all, we're trying to be very active on Stack Overflow. So if you have any questions that can be discussed publicly, feel free to post a question on Stack Overflow. That will trigger a notification in our internal system so that myself or one of my colleagues can hop on there and help you out. If there's something that's more private, maybe some confidential data or confidential information, you can also reach us directly through the developer portal. When you go to support, get help, you can fill out a form or send us an email, and that will trigger a notification in the same system so that we can still pick it up and get back to and help you out. And what will happen after the event? We will be sending out a wrap-up email with some details about, links to the recordings of these sessions from this event. We'll probably be sharing the slides as well, because that's something people have been asking for as well. And we will we'll also send out a link to a survey that we would really like to ask you to take for us. It won't take you, it will only take you a couple of minutes, and it's really important for us to get your feedback for you to let us know, what worked, what didn't work, what we could have done better. If you have some other ideas on what you think would help for these type of events, what do you think would help you? Because again, we do want to make sure that these events are really great learning experience for all of you. And if you're interested in taking your newly acquired skills to the next level, we have other types of events that you can check out, or other types of resources that you can take a look at, such as Forge Accelerators. These are these week-long sort of hackathons where you can bring your own idea for a prototype, something to build with Forge, and you can sit down with us virtually for now, but hopefully in future also in live. Typically, we used to run these events in different Autodesk offices around the world. So hopefully soon we'll be able to go back to that mode. So you would basically just travel to one of our Autodesk offices for a week, and we will sit down there with you and help you, help you implement your prototype within that 1 week time frame. And we have different lightning talks on some specific topics that customers also ask for frequently. So these are short videos that may provide the answers that you're looking for. So do check those out as well. And also take a look at our blog. This is where we usually publish articles on some very specific use cases and some very specific questions that our customers repeatedly ask. So things like, again, the example I keep using is, we've been getting a lot of questions about, okay, can I use Forge Viewer in an offline environment when I'm disconnected from the internet, right? And yes, we do have a blog post for that. Or somebody else might be wondering, okay, how do I combine point clouds with my BIM data? And we have a blog post on that as well. So you can just filter through and search for the terms that might lead to the learning resources, the type of idea and use case that you have in mind. All right then, and with that, that was all for me. I want to thank you for joining me today, for staying with me for all 4 sessions. And as I said, I'll be online for 30 more minutes if in case you have any questions or if you got stuck on anything. I want to make sure that you have your awesome customized your application up and running today. Right. Thank you and have fun.